Okay, we're now going to do combination world. Complement of a union. Let's just brute force. Okay. We need to apply if control. What just happened? Wait. We need to apply if dot intro. Intro hxab. Actually, wait, maybe we can do something different. Alright. Let's do rewrite. Can we do this? Okay, we can. Can we do this? Um, okay, what if we do a push meg? I think this is done. Okay, great. Easier than brute forcing. Complement of an intersection. Um, let's try the same thing again. So extension x, and then rewrite. These two are logically the same, but we can't RFL. We cannot. Okay, so we just brute force it. I'm going to just prove by contradiction and get a contradiction and get a contradiction. So, okay, other direction. Um, okay, great. Okay, so it sounds like just pure brute forcing, which we can do. rewrite all this stuff out. This is ugly, but it'll work. Okay. Actually, we probably do something else. Let's do as much as possible before breaking the cases. So, by contra, this right. HAB, HAC. No, it's an and. Okay. So this is before the split. This is after the split. Before the split, this is first condition. Wow, this is annoying. So false. Apply HAB to HX, HXB. Okay. Apply HAC to HX to HXC. HX should be renamed HXA. Intro H. Let's call it H1 for now and split it later. By contra H2 push neg at H2. I think now we start doing splitting. So our case is H1 with HXA, HXB, HXA, HXC. Apply H2 to HXA. Will this work? I can't believe that worked. H2 to HXA. Okay, we brute force that problem. Right, this tricky shortcut is easy. We are going to, hang on, I'm going to copy the statement here. Have H4, which is this, apply to A complement, B complement, and C complement. we're going to say that have okay. So now that we have this, we're just going to rewrite H2 until we get the answer we want. So, we're going to rewrite complement of intersection. Repeat is not allowed. Can't read. Great. Complement of intersection. Complement of this flashing thing's really annoying. Okay, and then I think we just do a bunch of okay, we're done. Last one, a tricky subset. Proof is tricky, but you should know how to get started. Yeah, so if it belongs in A, it should belong in B. And the way we're going to do this is that consider an element that belongs in A, and it does not belong in B. Then one of these will give us a contradiction depending on whether it belongs in C or not. So this is going to be intro X, HXA, HXB, by contra HXB. Right? I don't think by cases is allowed yet. Okay. We'll just do this and see what happens. Let's actually do H naught and see. So if X belongs in A and X belongs in C, then it belongs in this part here. But it's not belonging in that, so that would be the contradiction. So we have X in A cap C by apply and dot intro HXA, HXC. Okay. Have H3 which is going to equal A2, which is equal H2 applied to but this is going to give us a contradiction because X does not belong in B. So apply H3 dot left, HXB to H3 dot left. Alright, so I think that solves that case. So now we have this other case, which is X naught in C. I'm going to call this HC. HXC. Okay, so in this case, X belongs in this, but it does not belong in this part there. So how do we get this contradiction? Have HXBC, which is X naught in B cup C, by, how do you prove this? Rewrite neg union, push neg, apply and dot intro HXB, HXC. Okay. So now we want to get false. Okay. Okay. And I think that does it.